Hey, ladies and gentlemen, welcome to lesson 4.5. This is all about scatter plots and lines of fit. So a scatter plot is just any kind of a graph where there's two sets of data that are being plotted as ordered pairs. And what we'll notice on scatter plots is that sometimes the line is generally going upward. That's a positive correlation. Generally going down, which is no correlation, or we can't tell at all if it's going up or down, which means that we have no correlation. So we have positive, negative, and no correlation whatsoever. So we're going to be looking for generalized going upward, downward, or nothing at all. And that's what scatter plots with their correlations are. So here is our very first example. The graph below shows the average number of students per computer in Maria's school. We're supposed to determine whether the graph shows a positive, negative, or no correlation. If there is a correlation, describe its meaning. So if you look at the graph, things are generally going downward. So this would be a negative correlation. And a negative correlation in this case means that things are going downward. The number of students per computer as the years go on is decreasing, which means that there's more and more computers per kid and less students per computer. So that means that there's probably, hopefully, as we've gotten into 2017, we're almost 1-to-1. There's almost the same number of computers as there are students. Now, the actual difficult part of this specific section is making lines of fit. A line of fit is when the data points all align close enough to form a line, and a line of fit or a trend line can be drawn to model the trend. So if we have a negative correlation, we're going to draw a line that's kind of like the average line of what the data shows, and then we're going to be able to create an equation from that line to be able to predict things in the future. So here's our example. Make sure my face isn't in the way. The table shows the growth of the world's population. We're supposed to identify the independent and dependent variables, make a scatter plot, and determine what relationship, if any, exists in that data. So we're supposed to use a line of fit to identify any trends. So we're going to take this information and we're going to graph it. So our title is going to be the world's population. And then after that, we're going to put labels for the X and Y axis. So my X axis is always time, so this will be the years. And my Y axis would be the population in millions. So I'm going to use a tech trick here. We're going to put population in millions. And then I'm going to switch it to its side. Whoop. And then all we got to do here, folks, is label the units. So we went from the year 1650, 1850, 1930, 1975, 2004 for our units. So what I'm going to ask for you guys to do is to graph this information, and we will do the rest of this work in class. So you're going to want to get numbers over here that are counting by a set number. We got to get from 1650 all the way to our present time of 2004. That's not really present, but and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers here. So we're going to have a little break in the graph, and that's going to be helpful for us. So you graph this information onto your plots, and then we'll talk about this more when we get back to class, because this problem will be taking quite a bit of time. All right, folks, this is the Burma Nation. We're signing off.